So in this video, we're going to move on to some more complicated linear inequalities, this time where we've got the x on both sides of the inequality. So if we start off with number 1, we have 3 plus 2x is less than or equal to x take away 7. Now, before we begin, essentially, when I'm solving these types of inequalities, I would work with it in the same way that I would solve an equation, in the sense that in this case I would try and get to the easiest value of number of x's to deal with as possible. So you could, for example, subtract 2x from both sides and you could get minus x on the right hand side. Personally, I don't want to have to work with that. I want to just get x by itself if possible, a positive x, okay? So the tactics that you use for solving linear equations, rather, is the same here. So I'll subtract an x from both sides, okay? And then I could just subtract 3 from both sides. So x is going to be less than or equal to minus 10. And that's the answer to my first one, okay? So I'm trying to do it in as few steps as possible. If you end up taking an extra step just to reorganise yourself, that's perfectly fine. Number 2, x take away 5 is greater than 13 take away x. So I could subtract x from both sides, but I don't really want to get a minus 2x. So if I add x to both sides, I get 2x take away 5 on the left-hand side is greater than 13. So what you should find is that you end up avoiding multiplying or dividing through by a minus sign with these, okay? That's usually what happens. So I can add 5 to both sides, so 2x is greater than 18, and then divide through by 2, so x is greater than 9. So I'm just saying, you know, as we work through, you're probably not going to see that many examples where I end up dividing or multiplying by a negative number with these, because with the rearrangement, I'm essentially trying to avoid that from the outset. Not that it's going to cause me any problems, but it's really just to speed up my working. So number 3, we have 2 lots of x plus 4 is less than or equal to 3 lots of 3 plus x. Let's expand the brackets. So we'll get 2x plus 8 on the left-hand side and 9 plus 3x on the right-hand side. Now, I could, as I said before, I could subtract 3x from both sides to get the x's on the left-hand side, but that doesn't really speed me up anyway. So I'll subtract 2x from both sides to get that, and then subtract 9 from both sides to get this. Now, x is greater than or equal to minus 1. Personally, I don't like leaving my answers written that way round, so I could write it that way round instead. All I'm doing there is I'm just rewriting the inequality as I would read it, so from left to right, okay? That's all that I'm doing. I mean, I guess you could argue in doing that, you could see it as multiplying through by minus 1, and that would change the direction of the inequality symbol, and then adding an x to both sides, and then subtracting 1 from both sides, right? And this, I've got to exactly the same statement, okay, that I had before, but I've gone about it in some steps that I don't really need to take, okay? But it's just showing you that algebraically, what you're writing down there is nothing. You're not kind of like skipping steps or breaking the rules or anything like that. Number 4, 5 lots of 2 takeaway x is less than 3 lots of 8 takeaway x. Let's expand the brackets again, shall we? So we're going to get 10 takeaway 5x is less than 3/8, so 24 take away 3x. Now you could add 3x to both sides, but I'll get a minus sign. So let's add 5x to both sides. That seems a little bit better. So adding 5x to both sides, we're going to get plus 2x on the right hand side. Subtract 24 from both sides, we'll get minus 14 is less than 2x. And then divide through by 2, so minus 7 is less than x. Or if you prefer, like I do, rewrite that as x is greater than minus 7. Okay. Last one, number 5. 2x plus 1 over 3 is greater than or equal to 7 take away 3x over 2. So the first thing I'm going to do is I'm going to get rid of these fractions. I'm going to multiply both sides by 3. I'm going to multiply both sides by 2. So I'm going to get 2 lots of the 2x plus 1 multiplying both sides by 2. Multiplying both sides by 3, I'm going to get 3 lots of 7 take away 3x. And in doing so, the fractions have gone. I'm going to expand the brackets out. So 4x plus 2 is greater than or equal to 21 take away 9x. So let's add 9x to both sides. So I'm going to get 13x plus 2 is greater than or equal to 21. Subtract 2 from both sides. And then divide both sides by 13. So my final answer there is 19/13. Or rather, x is greater than or equal to 19/13.